We'll be starting the Kahoot here in just a moment. I saw someone saying they liked the song. It was Emma. Thank you, Emma, right there. We'll be starting the Kahoot here in just a moment. So get ready, everybody. We're going to send out an announcement to all the classes. No fault the Kahoot. Do you hear me in your walls, Brian? Hey, Philip, what's up? Philip's got all the answers. Philip's ready to go right there. Let's see. We're going to send out the announcement. Kahoot starting. And click here to join. Get some hype going in the chat. Okay, announcement going out to one class. And Kahoot starting to other class. Announcement going to other class. Click there to join. Got the chats ready to go. Let's go bring up the Kahoot. Get ready. We're going to go over to the code. We'll be starting here in just a second. Alyssa has her reviews tonight, I believe. People can post links for those in the chat. I'll probably pin the comments here in a second. Okay, let's see. Please tell me my Kahoot's saved. Please tell me. I made some changes to the Kahoot. I made it even better. Made the Kahoot even more awesome than it already is. Yes, it did change. Woo! Got an even better Kahoot. Bring it over to the main screen. And we got all the settings ready to go on this. Should be good. Randomized order of answers, not the questions, though. Okay. We are going to get started here after our introduction. Let's do the intro. Okay, hey, how's everyone doing? It's Not Wacky Wednesdays, but I just wanted to wear this shirt. Let's get the music turned up right here. Where's our music? We need to go to the disco music, and now we need to bring up that music. There we go. Joining the Kahoot. How many are we going to get in the Kahoot? Let's try to get 100. How many people do we have watching? Let's see. We'll throw out another 100 points. Mewbot's here in the chat. Abish is ready to go right there. Got a lot of great stuff. Got a lot of topics to review. Now, where can you go to review for test 2? Where can you go? Good to see your gauge. Where can you go to review for test 2? Where can you go to review for test 2? Close Carlton. Close Carlton. Sophia has it. Sophia has 100 points right there. The exam 2 review page, which Mewbot is posting in the chat. We're going to pin Mewbot's message right there. So Mewbot's got the review page right there. Make sure to go check that out. It's got a lot of review videos. Has anyone been watching the review videos? Did it not open a new tab here? Let me see. It did. Has everyone been watching the review videos, checking them out? You've got all different review videos right here, going over the chapter material. Just use it, have your notes out while you're doing it. Have your notes out today because we're going to be doing some practice here. The speed runs, you need to watch them, check them out, watch the reviews. Let's see how many people can get in. How many people we got in? 106. That makes my day worth another 100 points. I love it when we have 100 plus people here. That's awesome. You get scratch paper and you get the formula sheet. Scratch paper and formula sheet. Just exam 2 has a formula sheet. Caitlin, good to see you here. Scratch paper and formula sheet. So you can't have notes. Do not have notes for the exam. If you have questions, ask your instructor. I can answer them too. Exam 2 is going to be interesting. You got this. We know a lot of what's going to be on exam 2, like interpreting the R squared, the intercept, and the slope. We're going to put a 1-minute timer on the clock right here. But when are we going to get the formula sheets? Formula sheet. Where's the formula sheet? Good question, Andrew. Where is the formula sheet? You can use calculators. Can't use a phone. Can't use calculators that have internet capability. Where's the formula sheet? Where is the formula sheet? Review 2. Right here. It's right there. Exam 2 formula sheet right here. So stat homepage, review 2 page right here. There is the formula sheet. We start in the Kahoot here in just a second. Make sure to check it out. Exam 2 on chapters not 7 through 14. Check it out right here. The topics are listed right here. 7, 8, 12, 13, 14. Well, yeah, my gosh, 100 points right there. Jack got it right. Brian got it wrong. changing the chapter numbers all the time. You can print it off or write it down, but you can't put extra notes on it. You need to probably show it at the start of the test, just kind of show your form sheet. Be like, here's my form sheet. You still want to have extra things on it. So Jack got it right. Brian was wrong. The numbers always change, so I'm always like, what's the numbers of the chapters? Murder office hours, can we cover the practice? Yeah, well, Cassie, also, if you want to go over, and we can go over the practice problems, but where could you watch videos on practice problems? So if you're wondering about some of the practice problems, where could you see a video going over each of the practice problems? And it's like got little annotations at the bottom, so you can watch any of these right here, checking them out. It's good, but you want to sit down. The best way to review is to sit down and probably take the practice test. So Maisie right there, where is it at? Mubot's got it pinned right there. And anytime you type review 2, we're gonna start the Kahoot here in 30 seconds. It's right there. Everything review 2 is on the review 2 page. Mubot's saying go here for test 2 review. That's Mubot right there, our bot who helps out. And yep, there you go, Cassie. Thank you, Cassie, for asking. Maybe other people didn't know that also. But the videos right here can be really helpful. The chapter reviews, the review test videos, and the speed runs. So you get different types of reviews. But with that, we're gonna start here in 10 seconds. So join back in. We had 100 plus people. Let's see if we can get back over 100. So let's start up the Kahoot here in just a second. 129 watching. Join the Kahoot. Can we watch the Kahoot? Yep, this is recorded. All the videos are recorded. Watch them at any time. Okay, starting in 5. I am in the future, so when I'm saying this, just get clicked in. You can print it off or write it down. Don't have it open on a second screen. That way, that's tough for us to know. Write it down or print it off. Just show the thing and be like, here's my review sheet. Don't have it on your phone. I just don't have a sheet of paper in front of me to do that. 4, 3, 2, 1. Let's Kahoot. Here we go. First question of the day. And we will be reviewing during office hours, so swing by office hours tomorrow. Test 2 review time. 2, 1, 0. Quiz question. 2 events that can be easily added together must be what? Now, it's very important to know your terms here. Write down the definition of each of these as I say them. Dependent means the probability of one event depends on another. So that means, let's say, school being canceled depends on snow. So if it snows, school is more likely to be canceled. Independent means kind of the opposite, where if we said Brian drinking coffee and Darren drinking coffee are independent, they would not influence the probability of each other. But disjoint and mutually exclusive are the same thing. And so this is good we see this. So let's write down a table. Are you ready? You can get like a million word documents opening up. Who has ever written down this table that I am about to write down right now? You ready? You're going to see it here in a second. Please write down this table with me, as Word is just, I've got a billion documents and Word's getting mad at me. Oh, there we go. Okay, here we go. Please write down this table. Great job. Caitlin right there seemed to got it. These are the notes you need. So I'm going to insert table because my handwriting's so bad. And insert table, and I think that's enough. So what you need to know is we need to know the rule's name, the condition. Oh, come to class. I'll add a wrench next to your name during class. The math, and then also the word. So what is one of our rules in probability? What is one of the words we use in rules we use in probability? Who can tell me a rule in probability, which we just mentioned one right here? What is a rule in probability? I need a rule. What are some of the rules? There's 5 rules total. Addition rule. We have addition. We have complement, multiplication. We have the set of all events equals up to 1, and probabilities have to be between 0 and 1. First rule, probabilities have to be between 0 and 1. Second rule, set of all probabilities add up to 1. Third rule, addition rule. You can add together 2 disjoint / mutually exclusive events. Fourth rule, complement rule, I think is next. There's no, Brock would say. It doesn't matter. The numbers don't matter. It's that the complement rule is A or not A, add up to 1. And then multiplication is done when things are independent. So the condition for independent, or the condition for disjoint, condition for addition rule, is disjoint / mutually exclusive. Now, why do I put them both here? Why do I put them both right there? Think about why they're both the condition, and I put them on separate lines. Why are those both the conditions? Why are those both the conditions? They're the same exact thing. Mutually exclusive. Think about these 2 circles. Why are they disjoint and these circles are not disjoint? This is not disjoint and this is disjoint. Think about right there what it means to be disjoint. And think about to say, oh, the circles what each other, and then use the other phrase. There's no overlap. They exclude each other. Does that make sense? Now be careful. We can talk about dependent, independent here a little bit, but when we think about this right here, we want to say like there's no overlap. If one happens, the other cannot. Cassie said it perfectly right there. Now, technically, and be very careful on this, disjoint events are technically super duper what? Disjoint events are technically super duper what? Dependent or independent. And Cassidy said it perfectly that if one happens, the other can't. So if you're saying this happens, you know the other cannot happen. And they are super duper dependent. But does that mean dependent events are disjoint? No. This is a higher level understanding, this topic, this what I just said right here. So don't just blend the two words together. Because think dependent means if one happens, it tells you something about the other happening. Disjoint means if one happens, like let's say you make an A in the class, can you also make a B in the class? So making an A in Stats 101, can you also make a B? Making an A in Stats 101, can you also make a B? No. So using the words up here, making an A and B are very clearly what of each other. Making an A or B are very what of each other. Like they're what events. Disjoint. Because if one happens, the other can't. Does that make sense? They are technically dependent, but they're because they're super duper disjoint, there's disjoint. So the probability of A, we're going to write down this table real quick. We'll be right back to the Kahoot here in a moment, but this is super important to write down. If you notice, half the class missed it. So this is a good time to practice. And this is a long ago chapter from a time far, far away. What is the word we use when we add together two events? What is the word we use when we add together two events? Adding together two events, we use the word what? Or, like what's the probability of A or B? The multiplication rule, we need to check if they're independent. And then that's just the probability of A times the probability of B. And you know what? The formula sheet, I'm not even kidding. The formula sheet, check it out. Take a look. What do you notice you get right here? To add together two events. Here's the addition. Here's the or. Here's the mutually exclusive. The formula sheet literally has a lot of this right here. So if you understand how to do this, you'd be like, oh, that's the condition right there. We got the plus, we got the or, and then we got the multiplication rule down here with the independent and the and we got the complement rule. We got the set of all events equals up to 1, and there's another. These are both just the complement phrase differently. Yeah, so we need to know. Great job, Hannah, right there, and everyone noticing. We notice what we got, and then we got this right here. And then we just have to know what independent means. We have to understand these terms. Complement right here means it is with an E technically. There really isn't a condition. We can always just say that the probability of not A equals to 1 minus the probability of A. And a lot of times we use this in a way and it's not, we use the word not right here. What's the code? I will show you here in a second on the screen again, Abigail. I print off the formula sheet, can I write my own notes? Do not write notes on it, Chandler. So thank you for asking, Chandler. Also, you probably use the scratch paper during the exam. It would just, we don't want to see like notes on it pre-written out. You can write on scratch paper during the exam, but just be very careful. Show what you have during the exam. Be like, hey, here's my paper, here's this. You know, just show it all off. We don't want to think someone brought notes to the exam. So don't bring notes. Thank you, Chandler, for asking. You might have been saying, can I write on it during the exam? Probably use the scratch paper. That'll probably be the best. Use scratch paper. But thank you for asking. Good questions. Keep asking them. Back to the Kahoot. The code is at the bottom of the screen right here, or to the middle of the screen now, so I don't need to disappear. Who's in the lead? Who's in the lead? It's Purple Piranha and Purple Finch. Purple's the way to go, but blue's my color today. Tropical Kitten, Bold Oryx, and Happy Deer. Good to see you here. You can print off the formula sheet. That is correct. Here we go to the next question. Let's do this. Two events that have no influence on the probability of each other are said to be what? Kind of a review question right here. Two events that do not influence each other are said to be what? Oh, it was not correct. Thank you, Bish, right there, helping out. Bish helping out with the questions. So when two events do not influence each other, you would have something like, let's take coming to the Kahoot and getting an A on the exam. Those two things are probably what? Now be careful. Coming to the Kahoot and doing great on the exam sound like, or doing great on the exam is probably what we would hope of the Kahoot, or at least I would hope. So be careful. You can print it off and you can write down. Jerome right there. coming to the Kahoot and doing great on the exam are probably, I hope, dependent. And we might think doing well on the exam depends on if you came to the Kahoot. Does that mean you have to come to the Kahoot to do well? And we might not say correlated because it's not quantitative, quantitative. Good question, Hannah, or good comment, Hannah, there. So correlation only applies to quantitative, quantitative variables. But the reason, think about it this way, how well someone does on the exam might depend on if they came to the Kahoot. You could still do well on the exam if you didn't come to the Kahoot, but hopefully, and I would hope here, you're more likely to do better. Like the probability of you acing the exam is higher if you came to the Kahoot. So success on the exam might depend if somebody came to the Kahoot. Doesn't mean they'll fail if they didn't come to the Kahoot. Dependent just means what? If you have one thing, it would what the thing of the other. Dependent means what? I showed it here a second again, Rachel, and I'll mention this. You can always rewind at any time or pause the video. And Claire said influence. So one thing I want to point out, and thank you so much, everyone, for being here. You can always, especially, you can come back and watch the video at any time. And you can always pause the video. And I do suggest taking screenshots. Also try writing it down. But you can screenshot, you can pause the video, and it is recorded to check out at any time. And thank you for those questions. I want you to be taking notes during this, hence why I went back to it. Probability of one thing depends on another. And this flowchart here is very important. And the formula sheet has a good bit of it too. Thank you for asking right there. Who's in the lead? The purples are in the lead right there with the purple leaderboard. Look at this, a 12-point difference. That's milliseconds right there. Here we go, down to the next question. Bold Orcs, good to see you in Epic Gazelle, epically jumping up on the leaderboard. Here we go, third question. To multiply the probability of A and B, two events must be what? This is a good review question right here. We're just making sure you know this super quick. To multiply two events, the two things must be what of each other? Little review of probability. I don't think I have you show your ID. I can always check with the photo roster. That's always been my thing. Like if I have a question, I always can go to the photo roster. I have access to that. So sometimes I look it over. The problem too is sometimes like pictures are so out of date. Like, I mean, I had long hair like a month ago, so you know, I don't look the same. It's very hard to tell sometimes. So right here, where, if you had a question like this on the test, where would you go? Let's make sure we know if we had a question like this on the test. Yep. I always try to go towards the best. Like, I've cut out a lot of like room checks and stuff. That way we're not, I don't know. It's weird the digital age we live in. The formula sheet. Yep. So go over here to the formula sheet. And on the formula sheet, what do we see? Here is the multiplication rule right here. So have your formula sheet out. I'll drop this. Well, here, let's type the review 2 in the chat again. But with this right here, the formula sheet is allowed. Yep, the formula sheet is allowed. That's why it is out there. Yep. You can have, this is the official formula sheet. You can print it off. You can write it down. Just make sure to show it before the exam. Make sure to show it. So really good question right there. What do you need when you're doing disjoint mutually exclusive? That's to check for what? Or to like, if you're trying to do what with two things? Disjoint mutually exclusive is to easily what two things? Disjoint addition right there. Claire's got that down right there. 100 points, Claire. That's when you're adding two things, and those are just the same word. Where independent is the rule for multiplication, and dependent means we really can't add them. So, you know, we can do a weird question right here. Like let's say this. Let's do a weird question. Are you ready? Whoops. Now watch out. This is a trick question. What is the probability this semester in Stat 2-1 you make an A and a B as your final grade? So here, put prob A. Here, don't answer yet. Don't answer yet. Don't answer yet. Oh, don't answer. Don't answer yet. Don't answer yet. Okay. Here we'll go A, B, C, D or lower. D or lower. And the probabilities are 40%. People are too smart. Okay. Everyone answer. I know, right? So, but when you see the word and, what's the first thing you think of when you see probability of this and this? When you see the probability of this and this, what do you immediately think? Like, pretend you don't even know what's asking. You see what's the probability of this and this? I know, I should have told not to. You think multiply, right? So the first thing when we think multiply is we are going to say, are these two things independent, right? The thing is that making an A is very, very dependent on making a B this semester in one course, right? And as we said, they are completely what of each other? So they are completely what of each other right here. Making an A and making a B are completely what of each other? Exclusive, mutually exclusive, disjoint. So why is the answer 0? Because if you make an A, you can't also make a B. Does that make sense? You can't have on your report card this semester an A and a B for Stat 201. So when you tell someone the probability is 0, you're saying this cannot occur. So you'd say, well, how did I know to do that? Well, when things are disjoint, they can't happen together. If one happens, the other can't. So little tricky, you can't have 2 grades in the same course for one semester. Exactly. Now you could say if you repeat the course, of course, then what if we said this? If you repeat the course, then, well, you might be more likely to make a better grade. So your second time taking it might depend on what you made the first time. So it's going to be a different grade distribution. Those are trickier questions. I can't think of a good one to write for that. Nope, only A's are acceptable. I hope, I wish. But no, I'm proud. I had a student, want to give a huge shout out. They made a B as their overall grade, and they were so excited. I think I can say his name is just his first name. His name is Dave. And he was just, I sent him an email. I was like, you made a B. And he was just like, yes. Almost a decade ago now. But I still remember that. And he worked so hard for that. And I'm so proud of him. And he's a great guy. So if 2 events are independent, no. If careful, good answers, Caroline, there. If 2 events are what, we can easily add them. If 2 events are what, we can easily add them. If 2 events are what, we can easily add them. If 2 events are what, we can easily add them. Not dependent. Disjoint, mutually exclusive right here. This one right here. And the reason it was 0 before was because they are completely disjoint and they can't happen at the same time. Yeah, thank you, Will, right there. Yeah, no, I mean, I still want everyone to think you have to make an A. It's like, man, if I took like a English course, I'd be super excited to make a B in it. Everyone's got strengths. Everyone has things that they are not as good at, and English is one that's not as good for me. Is a disjoint condition dependent? So things that are, good question right there, Carlton. Things that are disjoint are dependent. What's the rule? There is no really rule for dependent. Things can just be dependent, like if A depends on B. So each one of these terms, what should you have written down right now? A what for each one of these, which these two are synonymous. What should you have written down for this and be able to provide examples of? Have a definition for independent, have a definition for dependent, have a definition for disjoint, and be able to come up with your own examples of what it means when something is dependent. That if A is dependent on B, then knowing A or knowing B would change the probability of A. If A is independent of B, then knowing B happens would not influence the probability of A. If A is disjoint of B, then knowing B happens means that A cannot happen, which means A is also 100% dependent on B. So it's a little tricky, and the chapter's a shorter one, but practice makes perfect. So check out the lectures, check out the homeworks. This is a very, very mathy chapter. Good stuff. Really good stuff, everyone here. We're practicing a lot. We got the purple prompt. Where'd the other purple go? Tropical Kitten, Rapid Mouse, Wise Bobcat, and Rocky Macaw in the lead. Here we go. The probability of roast jelly bean is 25%. If you eat 3 jelly beans in a row, what's the probability that they're all good? So the probability of a gross jelly bean is 25%. What's the probability of a good jelly bean? What is the probability of a good jelly bean? Just a good jelly bean. You eat a jelly bean, you're like, oh, it's a good jelly bean. Probably a very good jelly bean. Got some jelly belly. Jelly belly. Oh my god, you eat the jelly belly jelly beans. 75%. So think about this. How would we talk about this? Good to see you here, Aditya. Didi, awesome job right there. I love the answers. Let's throw 100 points. So your first jelly bean is what? Talk to me in a sentence right here. Your first jelly bean is what? Low-key. I don't mind toothpaste. I'd use it every night. So I'm like, it's not bad. So the first jelly bean is what when you eat it? The first jelly bean is what? It's good. What word are we going to put between the first was good? What next? The first was good. Think of a 3-letter word. The first was good, and the second was good, and the third was good. So we have good and good and good. Now, what about these jelly beans allows us to multiply? Because when we grab 3 jelly beans, the first jelly bean being good and the second jelly bean being good will what? Think about what allows us to multiply here and why this works, which we'll finish off with this. They're independent. Abby got it right there. They're independent, which means the second jelly bean being good, what's? The second jelly bean being good, what's? Doesn't impact the next jelly bean. That's what independent means. Like if this jelly bean is good, the next jelly bean, rock nose. It doesn't matter. It doesn't matter if it's good or bad. So each jelly bean will not be influenced by the previous jelly bean that we have in our hand because it's either good or bad regardless of the other jelly bean we just had. So really good job right there. The mathematics was, and thank you, Didi, right there, posting it, is 0.75 to the third power right there. The probability of 3 good jelly beans in a row. Now, it's going to get a little more tricky, and I will be writing this next one out, but try to follow along. Would it be 0.75? Yeah. What's the probability I pull a good jelly bean? 75. Now, this is technically sampling with replacement or from a super very large set of jelly beans, or like Jelly Belly tells us this is the probabilities, and we get a very large bag. If we had sampling without replacement, then the probabilities might change. If I say there's like 3 bad jelly beans, then the probabilities might change as we sample. Here we go to the next question, but the leaderboard first. Purple Piranha in the lead, and Tropical Kitten. Great job. Wise, Bobcat, Rapid, Goose, and Silly Wolf. Here we go. Next question is, multiple choice. You have an 80% probability of getting it right. With 5 questions, what is the probability you get at least 1 wrong? This question is a little bit easier than you think, because think about writing a sentence right here. You'll either get all the questions right or what? So you'll either get every single question right. I'm going to try to do this on the screen while you're doing it. So 2 seconds. Sorry, it's going to block the screen for a moment. So you'll either get every question right or what? All questions right or at least 1 wrong. This is everything that could occur, so it adds up to 1. Now, what can we change the or to? We can change that or to a what mathematically? What can we change the or to mathematically? Because these things can't happen at the same time. You can't get everything right and get at least 1 wrong. We can change it to a plus because they are disjoint. You can't get all the questions right and also get at least 1 wrong. So now, what's the probability of getting all the questions right? So what's the probability you get every question right now? The probability of getting all the questions right are what? We need to get the first right, and the second right, and the third right. What do you need to get? And the 4th right, and the 5th right. Great job. Good work, Abby. And then via a little bit of algebra, the answer is that, whatever it is. That's the answer. So the answer is, there it is. Here, we'll show it. You want to go to your calculator and go 0.85, 2, 3, 4, 5, and 1 minus. And there it is right there. Probability exactly not all right. How did we do? Decent. So these are the more difficult questions. These are like the top level questions. So what is the strategy for this? You need to write out a sentence. So try these out. There's many of these on the homework. These are probably some of the hardest problems. There's other variants of this that we use, but writing out a sentence, thinking about what you're trying to find, and if you have all the questions are right or at least 1 wrong, check out, there's a light bulb problem on this. There's a soda pop winning problem, soda pop, but good question. Only 40 got it right out of about 100-ish. So let's continue on here with the next question. Leaderboard shake up right there. Silly Wolf and Epic Gazelle, but Purple Piranha still in the lead. Oh. What is the first thing we need to do when solving a sampling distribution problem? This is a big thing you'll know if you're in my class. Be very careful. The first thing you need to do, and the formula sheet has a good tip for this. What is the first thing? Oh, nice job right there. Thank you, Didi, right there. So, probability of all right plus probability of not right equals 1 for clarity. Nice job. Extra 50 points on top of those 100. So, the biggest mistake people make. Great job. Now, mark notation is a quick second right here. Mark notation is good, but we're dealing with 2 different sampling distributions. So think of this as a flow chart. When you go to do the problems, why is it important to first figure out if it's categorical or quantitative? Why is that important to figure out first? Now, notation's super, and good to see you. Yeah, Caitlin. We'll go on a limb, make Caitlin a mod. We'll give you the standard mod. Why is it important to figure this out first? So you know which formulas to use. Exactly. There's different conditions. We've got here the success failure condition over here. We've got here the large enough n condition. So it's very important to know which one you're doing. The formulas are different. The notation is different. I think that you mark the notation. You could, and you'll basically know it. So that's a little bit of a tricky one. But if you look at a lot of the problems we were doing during class, a lot of times I would be like, okay, let's first mark cat or quant. So a little tricky right there. But before, because here's why I say this, and I do totally, that was one of the iffy questions I wrote. I've had people walk up to me on the test and they say, where is P? So what do you think they're asking? I can't find P and I can't find Q. And we have a question that says something like, UT knows the GPA of its students is 3.7 with a standard deviation of 0.2. The distribution, exactly. And so right here, they walk up and they say, well, I can't find this and I can't find this because they're trying to mark the notation. And then we have a quantitative problem where we have GPA. And that's where I usually see errors. Like I've had some students who get A's on the test who can't, they get stuck. So I don't want you to fall into that trap right there. I want you to realize the first thing I suggest doing, which you might be doing it by marking notation, is to first realize, is it quantitative? Is it categorical? And then that's going to lead you down the different notation. If you're wondering, we do have some notation review coming up right here. So stay tuned. Here we go with the next star, the leaderboard. Woo, look at that leaderboard shake up. So here we go. Remember, $20 Amazon or Starbucks. And I do want to say at this point, if you do win first, second, or third, make sure to email me from your UTK account. Tell me, hey, Brian, I won. And then tell me Amazon or Starbucks to send to your UTK account, first, second, or third. There you go. And Caitlin, good to have you part of the mods right here. Seventh question. When trying jelly beans, if you take 2 jelly beans, what is the sample space of good and bad jelly beans? Now, you have to think about everything that can occur. Now, be very careful because you have to think about everything that can occur and the order by which it can occur. What is everything that can occur in the order by which it can occur? So we have good and you're only taking 2 jelly beans, and we have everything that can occur in the order by which it can occur. Everything that can occur in the order by which it can occur. Got some bunnies in the chat. Morty's joining the chat. And I think this one's pretty easy. I hope we do pretty good on it. Good job. So this one didn't list both ways you could get a good first or a good second. You either get 2 bad jelly beans, 2 good jelly beans, or 1 good, 1 bad. And it is important to notice the order right there. Oh, he's in one of the intros. Maybe I'll play that intro again, or we'll do it as an outro. The sample space. And right there, Rachel points out the sample space is everything that can occur. So if you get 2 jelly beans and they can only be good or bad, then this is everything possible that could occur. There's nothing outside of this that can occur, and that's the sample space. Leaderboard time, easier questions. One does the order signify that if it's like BG or GB, then like you get a bad first and a good second, or a good first and a bad second. So a lot of times when we miss the sample space, he'll be back at UT. Maybe I could bring him down to UT one day. Oh, he'd probably freak out. Bunnies are they're high stress creatures, so they take care of me probably. I'm just kidding. So here we are, Purple Piranha in the lead, Wise Bobcat, Silly Wolf, Rapid Goose, and Epic Gazelle. Here we go. What 3 values will you have to write interpretations for on test 2? This is worth 12 points on the test. What 3 things? And this is very important. I mentioned this a lot in my class, so I want to make sure everyone knows this. What 3 things? Now, there's a lot of really good stuff on the screen right here. First thing we have is the multiplication, addition, and complement rule, which are 3 of the probability rules. We have QQ, straight enough, no outliers, plot doesn't thicken, are the 4 rules for regression. So QQ means 2 quantitative variables, straight enough means the line is going through the data, and no outliers means there's no outliers. And plot doesn't thicken means it's not thickening. RMSE, standard error, and variance inflation are things we do in upper level classes, but the 3 quantities we will be doing are R squared, slope, and intercept. Variance inflation. Oh, Caitlin, you know some variance inflation factor right there? It is the factor by which our variance has been inflated due to multicollinearity. Caitlin might know. What class did you learn that in, Caitlin? If so, really big, another 50 points on top of that. If Caitlin knows some multicollinearity variance inflation factor. Good concepts for upper level classes. Not covered in Step 2-1 though, unfortunately. Oh really? What's he do? That's cool. Yeah, tell him my 201 exam. My 201 teacher brought up, or not mine, but 201 brought up variance inflation factor. So anyways, here's the big thing. Grab a piece of paper right now and have your notes out. How do you know which variables X and Y in interpretations? Let's start doing that here, Artie. You got it. Who has a piece of paper and pen next to them? I want you to actually write this down next to you, because the next 3 questions are going to be a little bit easy. Next 3 questions are going to be a little bit easy. So get ready. And we almost a speed round. I think I put 30 seconds on them, or I hope it did. Here we go. Get ready for the next question. Here we go. Next question is, what is the interpretation of the slope? Now, the slope interpretation is, for each 1 unit increase in X, we expect Y to increase by B1. Let me start writing that down right here as you do that. For each 1 unit increase in X, okay. For each 1 unit increase in X, we expect Y to increase/decrease by B1 on average. So you know what we have to do now? We have to do an example. Now here's the problem. A lot of people think, I don't need to write this down, I need to practice. But if you write this down in the chat right now, you will be basically doing what you'll be doing on the exam. Does everyone follow me? What we're about to do right here. Slope is B1. I wrote B1, right? Intercept is B0. B0 plus B1x. Yep, DD right there. Y hat equals B0 plus B1x. That's the formula we use. They're good questions. Let me pin that. So classic is Y equals MX plus B. And so get ready. Great job practicing in the chat there, Emma. Get ready to start writing these down. Okay. So I know it sounds crazy, but if you solve this with me right now, you are practicing for the test. So I'd like for you to interpret it's one of my favorite ones. Oh, let's do this. So we've got pet expense and pet. Oof, I did the same Y and X. We've got number of pets explaining the pet expense. Does everyone understand that? Does your number of pets explain your pet expense? Now, this does have problems. It does have outliers. It might not be straight enough. There's a lot of things we can do, like a lack of fit test. That actually sees, there's not a problem with there is a problem with the linearity. Well, we'll ignore that for the moment. But where is the slope in the intercept? Now, this is the Y variable. We are predicting what currently? We are currently predicting what? We are currently predicting what? We are currently predicting what? I'm making it look pretty as we do this. We are currently predicting what? We are currently predicting somebody's pet expense. That's the Y variable of interest up here. We are using the number of pets to explain it. And if you look down here at the bottom, we have the coefficients all the way down here also. And there's the estimate of the intercept. There's the estimate of the slope. For each, and so basically you can say 1 unit increase in pets, but what's a 1 unit increase in pet? Think about, which that does work for 1 unit increase in pet, but I also have that underlined because what's a more common way to say for each 1 unit increase in pet? What's a more common way to say for each 1 unit increase in pet? And great job, people are practicing it. For each additional pet someone owns, for each increase in number of pets, but make sure, so let me read my favorite one here in a second. For each additional pet, I think Caitlin has a great one right there. We can predict $254.23 to be spent on average more on pet expense. Basically, we'll pin your message, Caitlin, right there. So Caitlin, almost perfect right there, and great job. For each additional pet, we expect somebody's pet expense. So if you look right here, for each additional pet, we expect someone's pet expense to increase by, and then we plug in that value right there. For each additional pet someone owns, we expect the pet expense to increase by $254.23 on average right there. So really good job and amazing practice, everyone. 100 points. This is what you want to be able to do, and you want to know where your slope coefficient is at. What do you notice? Where's the slope coefficient? It's with the what variable? The slope coefficient is with the what variable. Make sure, Isabel, to put context in there. So you have to make sure to do the context. Make sure, good questions. It's with the x variable. So a lot of great answers right here. I think Sarah has another great one right here. We'll pin Sarah's message. For each additional pet, we expect pet expense to increase by $254.23 on average. And I want a 7-letter word. You need what with all your answers. Every answer cannot be written like this. Everything I'm underlined here will need what? Great job, Janeki, right there. It needs context. You have to give the context by which you're interpreting. So great job. Do not forget to give the context. And get ready. It's another fastest fingers contest. You know I said there'd be 3 easy questions. So here we go with the next question. It's a fast one. What is the interpretation of the slope? So here we go. Let me bring up the notes here while I do this. So people are just clicking away. So when x is equal to 0, we expect y to equal b0. When x is equal to 0, we expect y to equal b0. Does everyone notice how this sounds? When x is equal to 0, we expect y to equal b0. And then we have to say, is this logical? And so let's think about this right here. When x is equal to 0, great job, Sloan right there, and everyone practicing. Philip and Ella practicing too. Is that what the question is that requires? That's what we're practicing here, Bish. You got it. When x is equal to 0, we expect y to equal b0. Ooh, nice mathematics in the chat right there, DD. So let's interpret this and see what we get. How would this go? So think about, we have the intercept right here. When x is equal to 0, well, x is going to be number of pets someone owns. So how is this interpreted? When x, number of pets someone owns, let people interpret. When x is equal to 0, we expect y to equal b0. So what do we do when we interpret this one? We need the full context right here. In that, Cassie, you might say that. So Cassie's got a pretty good interpretation. We probably would accept that, I would think. But make sure to fully interpret. So I would say, here's what I would say. So start off this sentence right here. So get ready to start writing it. When x is equal to 0, which you don't change what 0 is, we expect y, look at the y variable right here, to equal b0. And b0 is this value right here. What happens if you plug 0 in? Look at what the equation solves out to. If you plug 0 for x, it literally solves out to the intercept. When the number of pets someone owns is equal to 0, we expect their pet expense to equal to $342.6 on average. It is not logical because if you don't have any pets, you would expect not to have a pet expense. And we could say, I think it is good to add on average right here, just in case I don't have my graders take off, but that is the safest thing. Some graders prefer you to do that. You can always question these ones that are graded right here. There are other ways to interpret this, but do you know what happens when I say to people, like there's 20 interpretations? When I say to people there's 20 interpretations, or like there's so many ways to do it, like on average we would expect when this value is equal to this, that we would logically see a y equal to this on average. There's so many ways to do it, but if I don't give a structure on the exam, it goes haywire. There's just like so many interesting answers that I'm like, that one's not close. So write down these interpretations, little bit rote memory, and yeah, good stuff. Well, we have one more thing to interpret. Who knows what we'll be interpreting next? Ooh, leaderboard's locked up right here. What will we be interpreting next? Get ready. I'll say it. Any word or data analytics to be graded? They're not. They should all. Oh, did they not publish the results? Sloan, remind me. They should have published them. They might not have hit the publish. I'll make sure they do that. But I think they're all graded right now, so we'll do that afterwards. Thank you, Sloan, for that right there. R squared, here we go. Same thing. What is the interpretation of... Wait. Oh, whoops. I was copying the questions. What is the interpretation of r squared? So this is r squared. What is the interpretation of r squared? We'll cover this up right here. Oh, geez. Oh, geez. And let's go cover this up. There we go. And r squared. For everyone watching in the future, that is blank percent of the variation in y is explained by the variation in x. Blank percent of the variation in y is explained by the variation in x, and we'll be plugging in this value, not that. We'll be plugging in this, we'll be plugging in this, and we'll be plugging in this. So let's take a look at it for our problem. How is it interpreted for our problem? We could probably get it on the screen here, almost. How is this interpreted for our problem? We did slope. Oh, they all said slope. Oh, no. Well, yeah, slope, intercept, r squared. Dang it. I was making changes to this one because we've changed the content for this exam. We just did slope, intercept, r squared. Very sorry about that. How would this one be interpreted? 13.6% of the variation in someone's pet expense is explained by the number of pets they own. Does that make sense? 13.6% or 13.59% of the variation in someone's pet expense is explained by the variation in number of pets they own right there. And do make sure you know the last one was the intercept. We were pretty much saying that. Very, very sorry. I didn't realize I didn't change those. Hopefully that's the only error. I was just putting click here for these questions because it's a lot to write out for these. So I want to make sure you wrote this down. Thank you, Abish, right there. Every once in a while, there's a small error. 100 points for people catching that. I was like, oh, it says slope again. I didn't see that. So we did slope, intercept, and r squared. Slope, intercept, and r squared. Go back and take screenshots if you want, but those are the slope, the intercept, and the r squared. Back to your usually scheduled harder questions here with the leaderboard. Whoa! Someone clicked in the wrong spot, it looks like. Epic Gazelle on the lead. Where'd Purple go? Purple Prawn is still on the leaderboard, but Epic Gazelle, well, they were at the start. A little cheeseburger with a sandwich like Burger King over there. We got a unicorn with an ice cream on their head. I don't know what's going on. Here we go, halfway through. What is the best way to know the difference between p hat and y bar and p and mu? I.e., what's the difference between p and p hat? What is the difference between p and p hat? What is the difference between p and p hat? So be very careful. Like if you had to say, so p hat is the sample proportion, y bar is the sample mean, p is the true proportion, mu is the true mean. Very few people got this. There's a lot of correct information over here, but what's the difference between p and p hat? P comes from a what? P comes from a what? P comes from a what? Well, what do you want me to write out, Courtney? P comes from a what? Well, P is a proportion, and it comes from the truth. P comes from the truth. P hat is from a sample. So I added this extra part on here. What's the difference between P and P hat? Well, one of them would be for a sample, and this would be P and mu come from the truth, which is a population right there. So it is true that that's why a lot of people said this. P hat is for categorical and y bar is for quantitative. That is true right there. This is also true, proportions and means, but P hat and y bar. So imagine this. You go out and talk to UT students and 30 out of the 200 are from Knoxville. What can you calculate from that? So listen to the notation I'm giving you and think about what you have up here. You go out and talk to 200 students and 30 are from Knoxville. What notation do you have right there? What's X? You got it. Lane's on the right track. And then we'll talk about what this means right here. So Lane's on the right track. What is the notation? Miller's on the right track. You got a P hat. So what's all the notation? Shinna, that is correct. So what are the values I just said? I said 30, 200, and then what else can you get from that? And then I'll explain what it is for those. Well, you can't get a Y bar because it's not quantitative, though. Good answer, Sophia. You can't get a Y bar because it's not quantitative. You said, are you from Knoxville? So it's a categorical question. People are on the right track, X over N, but what's the notation on it? So be like, X is this, N is this, and then what is what? And then, but Jesse, that would be a good answer. That'd be Q hat, technically, Jesse. That'd be Q hat. So what is X equal to? And I'll do another version of this and just to quiz you again. What is X equal to? What is X equal to? So we talked to 200 students and 30 are from Knoxville. 200 students and 30 are from Knoxville. So X is 30, X is 30, N is 200, and then what's the formula for P hat? What's the formula for P hat? X is 30, N is 200, and then what's the formula for P hat? Now tell me P hat as a sentence. blank percent of my blank was from Knoxville. Blank percent of my blank was from Knoxville. And so tell me a sentence. And great job there, Claire, 100 points. Blank percent of my blank was from Knoxville. So tell me it as a sentence now. Like, try to put it into a sentence, like that whole idea. Like, I went out and spoke to people and blank 15% of my sample was from Knoxville. Exactly. So that's what you calculated right there. You said, well, I talked to 200 students, 30 were from Knoxville, 15% of my sample. And that's why it's a P hat right there. And it's not a P though. So UT tells you that it's actually the case that 18% of UT students are from Knoxville. UT has now just told you a what? UT has now just told you a what? UT tells you it is the case that 18% of students are from Knoxville. UT just told you P, the true proportion. Does that make sense? UT is like, well, actually, it's the case that 18% of students are from Knoxville. So they just told you P, the true proportion. And that would come from the 32,000 students, let's say, which is the what? That would come from the 32,000 students, which is the what? Not an N. I mean, kind of, not this. Yes, and great job right there. Claire's on fire. We're clicking every point button. Claire put the capital N right there for the population size. And Brianna's pointing it out too. That'd be the population size. Now, mu and y bar work the same way, where you might say you go out and talk to students and they had a GPA of 3.6. Give her a higher level. Oh, we're going to add some levels. So if you go out and talk to 100 students and they had a GPA of 3.6, what would that be in notation? You go out and talk to 100 students and they had a GPA of 3.6, what would that be in notation? I don't think the answer's been typed yet. The 100 students you talked to had a GPA of 3.6. That would be, we'll wait for a few, the right answer's been in the chat right now. So what is GPA? Is GPA quantitative or categorical? GPA is quantitative or categorical? It's quantitative. So 3.6, don't tell me a notation is the what of the students. The 100 students you talked to had a GPA of 3.6, so don't tell me a notation for it. Just be like, oh, that's the what of the students. It is the mean, but what kind of mean? You are correct. It is the mean, but what kind of mean? It's a what mean, though? It's the sample mean. Jason has it, which means it's what? If it's the sample mean, it's y bar. Does that make sense? So this slide right here is to denote a lot of the differences. So since it's the sample mean, it's y bar. Then UT tells you that actually the GPA of UT students is a 3.52. They just told you what? Well, this is what we saw in the data. Like we took a sample and saw. Does that make sense, Abish? We saw in the data when we collected 100 students as GPA of 3.6. UT told us now that the true GPA of students is 3.52. So that would be mu. That would be mu. Oh, did I point to y bar? And then mu is the true mean. So if UT says the true GPA is 3.52, that's mu right there. So that doesn't come from a sample. That would come from the population size. So really good review right here on like what N is, capital N is, what population is, what sample is. Very good stuff. Chapter 14 a lot right here. Here we go with the next slide. Next question. Let's do it. Thank you, Abish, right there. And amazing questions, Abish. 100 points. Keep it up. Keep up the questions. Here we go with the question. The central limit theorem is. Gotta be careful. It's super important. Not like the Pythagorean theorem, which is also super important too. But we don't use the Pythagorean theorem in our class. I mean, maybe we do. I mean, we do it to calculate distances, right? Shortest difference between 2 points. You can go Manhattan distance. That's a whole nother class. States over a long run, the repeated trials, we see the true probability. That's the law of large numbers right there. Law of large numbers. This is the law of averages, which is a fallacy. And it is a fundamental theorem of statistics. Now, this is very important to know. The central limit theorem is a fundamental theorem of statistics. Probably finished in about 35 minutes here. You should go about 90 minutes. The central limit theorem is a fundamental theorem of statistics. And it tells us two things a lot of times, that the curve is going to become more normal and tighter. And it's a theorem for a reason. And it's fundamental because a lot of distributions will approach the what, because the central limit theorem says we take a distribution like this and we sample of like 50 from it, and then the curves will start to approach a what? Is the symbol of by itself always the truth? The P is true, mu is true, sigma is true. Those are true right there. These are populations. it's going to approach the normal. And now, what would the rock say about the shape up here? Which, I mean, we could just say it was skewed to begin with. But rock would be like, that original shape is going to what now?
It doesn't matter.
Doesn't really matter because now we can model this with the normal. And why do we care about the normal? Because we have things like the 68, 95, 99.7 rule, which tells us the percent of observations within a certain amount of standard deviations. So it's fundamental because all of a sudden now the normal curve is way more useful. So this is very important to being like, what's the probability of this? What's the probability of that? Well, we can say the central limit theorem says we can use the normal curve because it's going to approach the normal as we increase the size of the sample from the parent population. So really good. A lot of chapter 13, 14 right here. Check it out. Big review. And let's continue on. So as the sample size increases, the data is predicted to become more normal and tighter. Exactly. Correct, Miller, right there. Will there be anything from the applet on the exam? There might be pictures. You're not required to use it, but there could be pictures. You never know. Here we go with the next question. Let's do it. The conditions for the sampling distribution of the sample proportion are what? Ooh. I think everyone will get this one right. I probably should have used the other one. What two colors are the only answers you should pick from right now? Right now, with your current knowledge, what two colors are the only answers you should pick from? You should only have two possible answers if you can narrow it down. Yes. Wow, I got it wrong. Wow, I looked at it wrong. More on nearly normal to come later. Another 100 points. Brian was wrong. It is yellow and red. And choosing between yellow and red, which a lot of people chose correctly right here, but choosing between yellow and red really comes down to what? Choosing between yellow and red is going to come down to what? Choosing between the yellow and the red answer, like success, failure, is going to come down to the type of the variable. We mentioned that here at the start, that choosing the variable from the start is going to be very important. And here's a very common mistake. Whenever people get to the third condition, they usually just instantaneously say what? They go random, 10%, and then they say what? And Sloan's right, we need to pause. They usually just say success, failure. They usually just go success, failure. And why do you think people usually say, oh, well, it's success, failure? Why do you think people usually just go, it's success, failure? Or they just snap. They just get stuck. They're like, I don't know why I'm snapping. Why do you think they usually just say success, failure for the third one? It's easy to remember, and it's the first one we learned. So that's what I've noticed. A lot of people get to the third condition. They say, oh, it's success, failure. But we have to pause and we have to say, okay, wait a minute. Am I working with a quantitative or categorical? Forget about the large event condition. Exactly. So success, failures for categorical data. That is correct. Exactly. And so make sure to pause before you get to the third condition and be like, am I working with like means like Brian was doing the GPA of students, or am I working with, are they from Knoxville, which is categorical? Very important right there. Great job on that question. Here we go to the next one. The large enough n states what? The less normal a distribution is, the larger n needs to be. 125, 100. The less normal a distribution is, the larger n needs to be. Oh, that's the capital N right there. Haha, Brian, you're tricking yourself. I think it was like 40, 45, 50 something. That was correct right there, Caden. I believe that was correct for the last question. Categorical is success, failure, and quantitative is large enough n. I know, tricky, right, Philip? Did I get you? Philip's like, bro. So this is a notation thing. The less normal a distribution is, the larger the size of the what needs to be. The less normal a distribution is, the larger the size of the what needs to be. Sample. Be careful. The less normal a distribution is, the larger the size of the population is wrong. Does that make sense? So very specifically, and we have steps for this. Our steps, do I still have the steps open? I don't think I do anymore. Let me see if I still have them open. It'd be great if I still have those sheets of paper open. Oh, maybe I do. 2 seconds. Looks like I don't. It's just saved. I had to restart. Oh, no, here it is. Good, we got it. Okay. What is the first thing you do when doing the large enough n condition? Sorry, Abby, right there. I try to write some tricky questions. Look at the shape of it. So you look at the original shape of it, and since this is, let's say, very skewed, your sample size needs to be at least what? If this is very skewed, your sample size would need to be at least 100. Now, it is true, and my Pearson question went into this, that it can always be more and more skewed, like very, very, very skewed. and then it'd be 500. So think about in your own words, the larger, or excuse me, the more generally, because the less normal it is, but the more what it is, the what n needs to be, such that the distribution of the sample means will be normal enough. Kind of use normal enough there a little bit, but the more skewed the original data is, then the larger the sample size we need for the distribution of means to be normal. So that's what large enough n means. One, look at the shape of it. We'll usually mention it. The more, and if it's normal to begin with, then n could be what, Philip? So it is true if it's very normal, then you don't need a large sample size because remember, it only becomes more normal and tighter. So I like to always ask this classic question right here. How large is an n of 2 large enough right now? So yes or no, is an n of 2, it's a poll in the chat, is the n of 2 large enough right now? Is the sample size of 2 large enough to meet the nearly large enough n condition? Is the n of 2 large enough? What's the first thing to look at with that distribution up there? What's the first thing to look at with that distribution? First thing you do is what? You look at its shape, and it's what? That distribution right there is what? So what is it? That distribution up there is what? It's normal, right? So how large of an n do you need? So we checked its shape. It's normal. Now you need an n of what? And Abish sees it. You need an n of at least 1. So if you have 1, you're good. So here's the thing. When we do the distribution of means of sample size 2, and these are the means of sample size 2, and we repeat the process, all of a sudden now we get a normal down below. So we met the conditions, so the distribution of means is normal. Now, if it is very skewed, you would need a larger sample size. So if you had something that's very skewed, you see how this is not normal? So this is where you need a what or what. So this is where the condition really applies because the original distribution is not normal. So you need a what or what. You might need at least 100. This might be skewed, so you need a larger n, right? So here's 25 observations being averaged together. And then this is the distributions of means of sample size 25. So every blue dot is the average of 25 points. And it might be normal enough, or we might even need a larger n, like an n of 100. So the more skewed that is, or the less normal it is up there at the top of the original distribution, the larger the n needs to be for the distribution of the sample means, because each dot down below, each blue dot in this distribution is the average of 25 random dots. And that's the condition 1, that those black dots are sampled randomly. So really good, big concept, big chapter right there. A lot covered just with that little bit. Where's my little bits? Wrong button. Next question. Let's do this. Leaderboard shakeup. Who knows who's going to win? Here we go. How do we check the 10% condition? Make sure to know your notation right here. How do we check the 10% condition? Like you go out and sample 200 UT students. Did you meet or fail the 10% condition? You go out and talk to 200 UT students and 50 were from Knoxville. Did you meet or fail it? Abby put meet. I like it. So think about this. Try checking it right here. That says, see if your sample size is less than 10% of the population size. So, and then Miller has a good answer right there. Miller says, you met it since 200 is less than 10% of n. Now notice, when I said all that, I actually didn't give you, which is n though? So n is, you went out and talked to 200 students. And then you might have to assume for a problem, or a problem might give it to you, what the population size is. Like, do you think, so put it this way, do you think 200 students is less than 10% of all UT students? Just logically speaking, there's 200 students somewhere. Is that less than 10% of all UTK students? I would say yes. And that means we meet it. That see if our sample size is less than 10% of the population size. So good practice on the notation right there. Also understanding, like, you can plug in those numbers. Like, is the 200 I took less than 10% of the 32,000 students? Yeah, 3,200 would be about 10%. So we took less than 10%. So really good check right there. I would even try to identify these things in a problem. Be careful. A lot of people just grab like X and N and P, and just be careful. Know your notation for the problems. Here we are with the next question. Mountain cat, mountain goat climbing up the leaderboard right there. I don't know, I said cat. I guess mountain cat's more common, but a mountain goat too. Here we go. Bold dolphin. Looks like an alien to me. Here we go. How do we check the success failure condition? So success failure condition is what it says it basically is. It has nothing, it's not really about binary data. We're on that in a moment. No, I don't think I included that one. That's on the Canvas content. It doesn't mean the data is binary. Now, it's kind of like, yes, successes and failures are binary. We want to see if there's at least 10 successes, at least 10 failures. So think about this. If UT told you 30% of students were from Knoxville and you talked to 1,000 students, how many successes would you expect? So UT says 30% of students are from Knoxville. You talk to 1,000 students. How many successes would you expect? How many failures? You bots excited in the chat. So you're actually doing the mathematics and practicing it by doing this right here. 300 successes. Because, and Claire might have it, P is equal to 0.3, Q is equal to 0.70, and then N is equal to 1,000. And just the practice right here of understanding that, okay, if 30% of students were from Knoxville, if I talk to 1,000 students, I'd expect 300 to be from Knoxville. Now, that's not saying you will see that. That's just the expected amount of successes in a sample size of 1,000. And we can also draw the sampling distribution too, and that would also be the expected sample proportion, mu p hat. Great job, Kaylin, right there also with the notes. So P is actually equal to mu p hat, which is the expected sample proportion. That's saying if I take a sample, I'd probably expect to see about 300. So there we go, or 30%, we should say. Next question. Oh, gentle lizard. Here we go. The success failure condition states which of the following? Oh, I did do it. Yep. To get NP, we multiply N by the probability of, yep. Well, it's N times the probability of whatever success is. Like 30% of students are from Knoxville, and we're doing 1,000 students. Great job, Caden, right there. 1,000 times 0.30. So be very careful. I try to put some tricky stuff on here. Black Griffin, sad Griffin. Good job right there. You need at least 10 successes. You need at least 10 failures. Now, your data is technically what right now? Asking students if they're from Knoxville. If a question asks, what is the expected value of similar? Yeah, Jack will be doing some of those here soon. I got some of those coming up. Needs to be categorical. So is a student from Knoxville would lead to successes and failures. So is a student from Knoxville is a categorical question right there. That also leads us to the start where we identify what kind of question we're dealing with. Make sure to do that. Here we are with the leaderboard. It's all locked up. Epic Gazelle in the lead, but you never know. Here we go. Probability of making a shot is 0.30. What's the complement? Super quick right here. Easy question. Easy question. If making shots are independent, what is the probability of, let's say, making... Let's try this. What's the probability of missing 2 shots in a row? What's the probability of missing 2 shots in a row? So what we could say is, you have right here, you will either make 0, 1, 2, or 3 shots. What have I just listed right here? These are the events. And this is the probability of the events. If you take 2 shots, I've just listed what? The probability of make is 30%. So I have just listed the what? What have I just created? This thing in here is a what? Sample what? Because you will either make 0, 1, or 2 shots. This thing right here is known as the what? Sample space, right, Lane? That's everything that could occur. And what do you know about all the probabilities inside of it? What do you know about all the probabilities? All the probabilities must what? Must add up to 1. So we could continue filling this out. We could write this down like you'll either make 0, which means you miss and you miss, or you'll make 1. The interesting thing about this other one right here is there's 2 ways it could occur. You could make and then miss, or you could miss and then make. So you could solve this out right here because there's 2 ways it can occur. You'll either make the first, miss the second, or miss the first, make the second. And then you can solve that out or just use complement rules to figure it out. Lots of ways to solve that one out. So pretty good stuff right there. And leaderboard time. Epic Gazelle, Brave Dove, great job right there. Top of the leaderboard. Bold Dolphin, though you never know. And Gentle Lizard, good to see you. And the Gout. The law of averages is a fallacy. The truth is what? So NP equals population times success rate. NQ equals... good question right there, Caden. NP is population size times true proportion. And NQ is population size. Oh, wait, it's capital N. No, sample size. What am I saying? Oh my gosh, 2 seconds. NP is sample size times true proportion. And then NQ is sample size times complement true proportion. There we are right there. Thank you, Kane, for asking that right there. People did really well on this one. Thought it was an easier one, so I want to make sure we got the comments in the chat. Past events do not influence independent trials. That's the truth right there. The law of averages is a fallacy. And this is the law of large numbers that we will see the true probability of an event in the long run right there. Past events do not influence independent trials. Very, very true. Okay, leaderboard time. Ooh, Purple Piranha back. Haven't seen you in a while. Good to, ooh, this is very close. And remember, you're here for knowledge too. It's not just about winning. With 4 more questions. We know UT is 20% freshmen. We sampled 200 students and 30 report being freshmen. What is N? Nice and easy notation. We'll be doing some more difficult ones here in a moment, so have your calculator out. Make sure to have your calculator out. This is the easy one. I hope everyone does well. I hope we get like 80% correct on this. We know UT is 20% freshmen. So mark the notation here before we get to the next problem, because they're going to use similar numbers. So what is, we know UT is 20% freshmen. We sampled 200 students, 30 report being freshmen. Oh, remember, this is everyone who's here. What is N in notation? N is what? N is what? So what is N in notation? The sample size. So mark all this notation as practice right now. What is 20%? What is 200? What is 30? And what can you solve from that? So mark all the notation. So what you'd want to do if you ever got to a problem like this is get your notation ready and say, okay, I got to solve the notation. And so what do we got? Well, then that is sample size. So that's population size. So it might be like the population of UT, good question right there. So I would say there are this many UT students, like total population size. And great job, Lane, right there. I think Lane has everything. So we'll throw 100 points and good questions. This is P, which is true proportion. We can actually get Q from that. And then this is N. This is X. X over N equals P hat. There we go. So good practice. Look at all this notation we can find from just 3 numbers. With 3 numbers on the screen, you've got tons of notation with X and N, P hat and Q hat and P and Q. It's very important to keep all of this straight. We know UT is 20% freshman. So if that's a fact of reality, then it's 20% is the truth. Since 0.20, what is 40? 40, oh, what is 40? So NP is equal to 0.2. What does this mean? If we took a sample of 200 students, what? If we took a sample of 200 students, we would what? If we took a sample of 200 students, we would what? If we took a sample of 200 students, we'd what? So what does that 40 mean? We would expect to see 40 students be freshmen. if we took a sample of 200 students, we'd expect 20% of them to be freshmen. We'd expect 40 freshmen. Now, we didn't see that in our sample. This is what we saw, and this is what we expected over here. Just like saying, well, if 20% are freshmen, we'd expect to see 40 freshmen. So this is the expected amount of successes right there from the truth. Good questions right there, Shinna, 100 points. It's just important to understand what we're solving for, what it means. The success failure condition tells you the expected amount of successes and expected amount of failures. More notations coming up, more notation questions coming up here with Purple Piranha. Woo! You were there at the start. I'm rooting for you, Purple Piranha. I love that that's a great character right there. Looks like there's a Pokemon that you can only get in Hawaii that looks like that. I do not have it. We know UT is 20% freshmen. We sampled 200 students and 30 report being freshmen. What is P? Go Purple right there. What is P? So we just marked all the notation. What is P? And also by knowing P, what did you find? What do you also know? What do you also know by knowing P? So P is the true proportion. You know Q? Yeah, Bish. Actually, I wasn't thinking that. 100 points of Bish. You know Q. What else do you know? There's another quick thing to know also. Once you know P, you know Q. But if you're doing sampling distributions, you also know what? What do you also know? What you would expect to see in a sample. You don't know P hat, though. P hat is what you see in a sample. So you don't know what you saw in a sample. You know the mean of the sampling distribution, so you know the expected sample proportion. It says mu, but I like to say expected right here instead. I know this is a little bit confusing, but it's like the mean of the sampling distribution, which is the expected sample proportion right there. So the expected sample proportion is equal to, and be very careful, if you say mean, that might not be enough. It is the mean of the sampling distribution for p hat. So what do I prefer to say for this again instead of mean? I don't usually call this the mean. It is the mean of the distribution. That is very true. But I like to say it's the what? It's the center of the distribution. It's the mean, but it's the expected sample proportion. Because if 20% of UT are freshmen and I took a sample, I'd expect a what? A what of what? I'd expect a what? If 20% of UT are freshmen, in my sample proportion, I would expect 20%. Does that make sense? If 20% of UT are freshmen, the truth, I would expect a sample proportion of 20%. So that's where it's a little tricky. Expected sample proportion of 20%. That's what that means right there. It's the expected sample proportion, which is the center of the distribution. So when you draw out the distribution, it would go down here at the center of mu p hat right there. So that would be the very center of it. Little confusing. I do agree with that. The first semester I taught it, I was like, what? I was like, I haven't done this kind of stuff. So it's very important for industry. If you work for a company like Eastman, where they're doing products and they would want to see what is the expected values. So it has a lot of application for jobs right there. So we go to the next question. I just don't do manufacturing. UT is 20% juniors. From 80 students, 30 are juniors. Find the mean of the sampling distribution. Who got this one in 1 second? Who got this one like instantaneously? The mean of the sampling distribution for p hat is just what? This is why I was covering it. The mean of the sampling distribution is what? It's 20%. Because what are you finding in notation? Hannah has it right there. It's p. So that's the thing. It says find the mean of the sampling distribution. So if you go to your notes, this is the mean of the sampling distribution. So in this problem, we need to find what? So say it again in the chat. It says find the mean of the sampling distribution. Find the mean of the sampling distribution. And we're asking, are you junior? So are you juniors? So right there, Miller, great job in the chat. So all we have to do for this question is find what? All we have to do for that question is just find what? Because it says, what is the mean of the sampling distribution? So the mean of the sampling distribution p hat, all we have to do is find p. And p is the true proportion. So the question says, UT is 20% juniors. So then we just say, well, okay, well then let's just go find that. Now be careful, do have your calculators out. I think the next one is a required calculator question unless you're, well, it's got square root in it. Hint, hint, hint. Okay, so let's get ready for the next question. I'm gonna give you a 5-second countdown. 5, I've been warning about calculators. 3, 4, 3, 2, 1, here we go. We know UT is 20% freshmen. We sample 200 students and 30 report being freshmen. What is P hat? That's not too bad. What is P hat? You got this. P hat is the what? It's the sample proportion. It's the sample proportion. And really great job here, everyone, on this Kahoot. Looks like there's been like almost 5 million Kahoots. Is that real? A lot of Kahoots. Kahoots are very popular today. Great job, Miller, in the chat, giving the answer away. And I like that, Miller. No, do show the mathematics. A lot of people wonder how to do this. Really good job, Jet, showing it also. Good work. Process of elimination, yeah. This right here, that's X, that's N, that's P hat right there. So good job. Get ready for the last question. I've been warning about the calculator. Here we go. It's going to be super close. Anyone's game here at the end. Here we go. That is correct, Jeremy. P hat is X over N. UT is 20% junior from 80 students, 30 report being juniors. Find the standard deviation of the sampling distribution. Ooh. You could be like, if you're in the lead right here, you could go super quick because you could probably narrow it down to 2. You could probably be super quick. Famous quote. Quote 191 right here. Quote 191. P times Q over N square root. P times Q over N square root. So with P times Q over N square root, we need to find P. P is 20%. Q is 80%. Over N is 80. Square root. P times Q over N square root. It does have a capital N. Ooh, we should fix that. Darn it. Let me go fix that. I do have to fix that. P times Q over N square root. 2 seconds right here. We'll find out the leaderboard in a moment. I got to edit this. Use lowercase n. There's a student typed that. I think it's a student who wrote that, but now it's fixed now. Quote 191, P times Q over N square root. And the answer is right there. The answer is blue. So good job right there. P times Q over N square root. And it's time for...
Where am I at? Wait, wrong voice.
Tiny Brown. Let's do this. Here we go. Let's go to leaderboard. And in third place. Who got third place? Roll out the red carpet for Bold Dolphin. Make sure to email Brian. No worries, Kimberly. Good job. And Brave Dove. Did the purple win? Did purple win? And in first place, it is Purple Piranha. Holy mackerel. Came back with 20,000 points. Gentle and adorable. Great job. Make sure to email Brian. Purple, you came back and you won with that Pokemon on your head. What a comeback right there. Was it Sarah? I don't know. I'm Tiny Brian and I'm out. Woo! Bye!
It's got like a new thing right here. View summary. Get feedback. Oh, you can play again? Get feedback. What's the get feedback? Players give your feedback. Wait, you can type feedback? I'm going to block this for the... I don't know if people are going to type. Whoop. Over here on the main... Oh, what am I doing? Show feedback on screen. Let me see the feedback. Oh, wait. Oh, no. It's got a feeling and a recommend? Game rating. This is cool. Whoa, okay. I like this. This is neat. Learning outcomes. Okay, so like it's like, how do you think about the learning outcomes? And game rating. Got a 4.7, maybe out of 5. Recommend. And so we have people feeling mostly good. I like that. But everyone who stayed till the end. Uh-oh. There's a not so happy feeling right there. So, oh, thank you very much, Caitlin, right there. It drives around. Oh, another. Uh-oh. Someone said not recommend. They said I didn't learn. Oh, no. Thank you, Caroline, right here. I definitely put some questions that I know are on the exams. Do not take the Cooter phone if you have a small phone. So here we'll go view the summary. You can see which ones were the most missed questions. So these were the questions 13, 12, 15, 25. We had a lot of missed questions. So if you take a look at, had a lot of missed questions. What are the 3 values you have to interpret on the test? Shocked that one had... a lot of people put QQ straight, a lot of no answers. Oh, you see, we started losing people here. And that's a bummer to me that, well, I guess if we remove the no answers, we can't. But that's where we started losing people later on. So by the end here, or especially, we have like no answer to the question. Yeah, so fundamental theorem, I remember that one I saw a lot of people got wrong. So here, I'll just show these right here to end. so people can write these down if you want or take screenshots on what it is. This one I know caught a lot of people, just small difference in notations. That was the last question we had right there. We lost 96 people by the end. No. So how do we check the 10% condition right there? See if the sample size is less than 10% of the population. The multiple choice one we had right there, we had already lost 49 people. No, it's practice makes perfect, everyone right here. And there's the answer to that one. And there's the answer to that one. You're welcome, Reese. Great job right there. Just showing these off right here for people. It does say practice makes perfect. So, and here we go to the next one. And the next one. And there's that one. This one right here, make sure to know the difference between disjoint and mutually exclusive. Yeah, I've had it happen to people that they've had to rejoin. So yeah, that's really good right there. Team up for a rematch in Tallest Towers. What in the world? I don't know. Maybe Kahoot's got some new games here. The no answer sometimes is when people are thinking on it. Oh, yeah, that too right there, Sloan. Well, head over to Alyssa's review. We did a great job with this review right here. But until then, here we'll do a Morty the Bunny outro. So get ready right here. If you stay till the end, you get to see Morty the Bunny. So we'll do Saved by the Bun. Here we go. Saved by the Bun outro. You're welcome, Sloan. Our confidence intervals or margin of error on the test. They're on the last. I think Terry removed those. Confidence intervals are not on this test. Confidence intervals are not on this test. Good question. I think that was an error, and I thought Terry removed it, but confidence intervals and margin error are not on this test. Here's the Morty outro. Bye, everybody. Bye. See you all today.